Very good morning. Under the able guidance of DGCSIR, Dr. N. Selvi and Head IPU, Dr. Vibham, CSIR IPU has started a monthly lecture series by inventors and innovators in the month of April 2023. First lecture of the series was held in May 2023. Today, we bring to you the third lecture in the series by Dr. Saptarshi Sasmal, Chief Scientist, SCRC. I would like to give a brief intro of Dr. Saptarshi. Dr. Saptarshi Sasmal joined CSIR in 2002. He is a BE ME Civil Engineering and is a PhD in Civil Engineering with a degree from University of Stuttgart, Germany. His PhD is from Germany. The title of this Performance Evaluation and Strengthening of Deficient Beam Column Sub-Assemblage under Cyclic Loading. He joined CSIR in 2002 and has been with CSIR for 21 years. He has 127 publications in journals and reviews. He has guided 19 MTech students and 6 PhD students have worked under him. 2 of them have completed their. He is a member of editorial board in 2 journals and is recipient of various awards and honors. He is a fellow of National Academy of Engineering. I would now like to invite Dr. Saptarshi Sasmal to give his lecture today. Dr. Sasmal, please.
Yeah. Thank you, madam, for such a generous introduction for me, and a very good morning to all of you. I think it is a very rare opportunity one person as a scientist gets to talk to the entire CSIR Fora, that to talk about some of the works that we are doing here. So that we are very fortunate to have that opportunity. And I am also joined by Dr. Srinivas. Both of us have actually joined together to work and to give this technology. So I will just give a brief of the whole thing. After that, I will be, and also that will be open to discuss, or if you have any query. So if you permit me, I will just share the presentation slide.
Yeah, please.
Is the presentation visible to all?
Yes.
Okay. So basically, that I'm going to talk about this portable, lightweight, foldable module for this makeshift hospitals and other needs. I think all of you that who have seen that announcement, that you know that the title of the technology that has been developed here. Basically, I will just give you a brief outline how this has happened. Basically, it is not our primary focus of our research that we do in our daily life here. So it has started in the year of 2020, that you know very well that there is having a peculiar situation arise that time, that we have to really do something which we had never thought of. So basically, that was the requirement during the Corona time. And there was a need for the quickly developing the structures for the temporary and the quarantine hospitals, and even in the village and the remote places. So that was the requirement. I think being a scientist, being a civilian, that was the requirement imposed to us. And being the structural engineer, that we felt that is the time that we should stand up and to do something. And then that we thought that, so to meet the needs, so what are the possible solutions? So out of the solutions that we felt that developing the innovative concepts for the fast, lightweight, modular, and easily transportable structures, so which should be structurally strong, and also it will be meeting the other criteria so that it can be used by the people. then when we are thinking the whole solution, the additional requirements also came up to our mind. And also we had discussed with many stakeholders. And at that time that we had understood that not only a particular type of structure or particular space, we also require to meet certain additional requirements, such as this should be having a customized design, and the utilities like that mechanical, electrical, and the plumbing requirements also have to be there, because the time was too short and the requirement is too high, and it is regarding the health. So those requirements of the MEP requirements were the must. And there was also having a prevailing the practices and standards for this. If you want to use as a hospital or as a quarantine place, that's having a standard that also that have to meet. And so along with that, that you see that there should be the technically soundness should be ensured. And as a scientist, that we can give many solutions, but the question comes that whether the industry is ready to take it forward to scale it up and to put into the market. So those were the boundaries that were given to us, and on that boundary, that we have to see that whether we can bring some particular solution. In the meantime of the thought, the number of the COVID cases were exponentially rising. And so the requirement, what we had started first thinking, the number was also coming much more, that we need to have to think for a much bigger, much more comprehensive way. And in that process that we also had added 2 or 3 more requirements, is that it should be cost effective. Naturally, that should have that. And it is not about a quarantine or a small bed system, but it should be having a capacity of a 50 to 100 as a cluster. And it should be also ensuring the transportability. So this is having the additional requirements that came up as the time gone by. So if I have to be precise, may I request somebody to just mute that? So to be precise, so it was the month of May of 2020. That was the thing that we thought that, okay, let us go ahead and do something. So that first 2-3 months that we have taken for the whole thing. Okay. Now in the entire process that we thought that the technology development, let us deconstruct into these steps. I think these are though it is a part of the usual the TRL guideline, but as for the structural engineering, that we have to really customize the requirement to meet the TRL, that how we should go forward. So first that we have so understood the need, then we have conceptualized, then the laboratory, and after that we go for the prototype design and the demonstration and all. Okay. So first thing is that understanding the need. So first need was the identify the challenges. So if we really have to do something portable, foldable, lightweight structure, and which meets the requirement of all the things that I was mentioning about, so that there is having some challenges. It is having a technical challenges, and also having a feasibility related challenges as well. After jotting down those challenges, that we saw that what are the available solutions. So the makeshift hospital is not that this is the first time that we are making it here. So around the world, if you look into, there are having many ways or many forms or many structural configurations are given, which can be treated as the makeshift hospital. So out of all the available solutions, and that we have understood the specific requirement for the new technology and the solution. So basically that we have come out into the 2-3 things, that we need to set up a makeshift structural system first. Then that you have to develop that an innovative concept that how we can fold and how we can make as a modular system, but using all the utilities that it should have. And as a structural engineer, that we have to inherently ensure the stability, repeat usability, and the durability. And out of all the things that we saw that whatever is there in the market, if you see around the world, many countries were having it. So it was not meeting the requirement that we were requiring at that time. Right. So then that we have made into the conceptualization and the preliminary design of the foldable module and the cluster. So basically, when we started conceptualization, different types of the folding that we had tried and attempted, and that we have thought that what are the different possibilities, because not only the unit wise that we have to see that whether they are possible, that is possible. Also, as I had mentioned, that the requirement was revised in the month of May or June in the 2020, that we have to give a solution for 50 to 100 patients, so it should be like a cluster. So that unit should be a form of a cluster, so that when we transport it and fit it, it can be made ready for the user with no time. So this concept that you have seen, that was having a foldability, the concept in a vertical foldability, horizontal foldability, even a hybrid type of foldability also, that we had checked it. But the major concern was that it should be very fast. The number of people required for doing so, the very purpose of making the whole thing, it will be defined, right? So then what we did, that we had not gone into the scale, that the total module and how it has to be done. We made a very small model in the laboratory, and I should tell that during that time we were having a pandemic, and that was a complete lockdown situation. I think no traffic, nothing was there, but we were given a special permission to come to the lab and do some work for this one, so that we did that one. And with that conceptualized foldability that we have made it, and in the laboratory that you have seen by using that overhead crane, that whether that thing is happening correctly. It is not about member, not about design, it is not about the disposition of the geometry. It is more about that if I fold and unfold, the entire thing should be working well, and that you have to see and improvise anything so which is hindering the requirement of after folding it should take the minimum size. So then that you have seen that with the small sections, I think they're 1 meter by 2 meter that you have done it, and that we have seen that yes, that is happening. Actually, basically that we have made whole thing, and I want to emphasize here is that, so this, though it is a miniature version, but you see that if you really look into, actually this is the space so which will be used later for the door, and this is the space that was made so that it will be used like a window. So we have to see also the structural mechanics part also. So it should be having adequate strength and stiffness, and also that we should meet the requirement from the user point of view. So when we made that small demonstration, small that type of fabrication, that time also that we saw that whether we can incorporate all those requirements in a scale form. And very happy to say that that has worked well. And when we had gone back again, and that we saw that that was very compacted, and it was like just having I think the 10 centimeter with that one depth was there, and that can be like a box that can be taken it forward. Then that we have found that okay, this has done well. So it was in the month of June of 2020, but still that was under the lockdown, and that we are having the problem of the material, man, and all the things. But the requirement is that you have to do in such a way it should be optimized section. It has to be used. So it is not about the structural requirement, because the scenario was like that we have to see so how minimum material it can be used to deliver the product. So then that we have seen the different modules, and also that we have started working with stakeholders and the construction industry. So we had to take it further. So that we had been given an impression that if you have to transport from the one place to another place, or from the one city to another city, a size of a 6 meter, that should be fine, because it will be taken as a heavy duty trucks it can take. And that was having a specific requirement was that after folding, the size should be such that I should get less than a feet, right? So there having two boundaries are there, which should be in the completely folded stage. So what should be the size? Because this was the size given it a feet. Because if you make into a one squeeze form, you stack 5 to 6 foldable, portable hospitals on the building in a single transport. And the size unfolded stage is like that because the 2.8-meter height is required because they wanted to mount the fans and all the things. And since it is for the patient, so that's having some window requirements for that. So 6 meter by 3 meter was the plan area, and the 2.8-meter was the height that was given in the unfolded stage. And the challenge was to make it into the 0.3 meters that when it is getting folded. So with that different mechanism and in a full scale now that we have gone into the full scale, we have done the design for the dead load, the floor load, and the wind load. And because it is a very light structure, the earthquake load that was not the major criteria for this. And for the every load case and the load combinations that we have done, and we saw how it is behaving, and so what is the maximum deflection is there, so that it should not damage or it should not disrupt some of the utilities which will be mounted in the portable structure. So then from the structural point of view, that you see the bending moment, also the shear that we saw, and the stress member stresses. And with the thing that we have started designing those sections. So basically it was used as a tubular section so that it will be light in weight and it will have higher stiffness. And that we have made the things in such a way. But one challenge was there, so that you can also appreciate is that at this point that was having some hinge at the mid height. So the mid height, there is a hinge, means basically if you give the lateral load, it will try to collapse. So now that you have to give something, the extra mechanism, so which will be used as the additional path for the load transfer. But when I want that to be like a hinge and getting folded, I can remove that like a plug, and so that it can be folded easily. So after that whole design that we have come out with these sections, because I think some of you that who are not from the structural background, so it will be not that interesting. But the people who are from the engineering fund or the civil structures, they can understand that how light are they. So they have been used. There is a minimum and the optimum sections that was used to cater for dead load and the wind loads. Okay. So now this is at the full scale. So that as I was talking at the miniature version also, that was done, but in the full scale, you see this is the door and this is the window. And these members that was made in such a way to actually it was into the stiffness to the structure, so that under the window that will be giving the less deformation into the structure. And if you see, this was the actually the floor that on which the hospital that will be sitting. And because there will be many machineries, because that that oximeters and all the things that is to be put here, so this has to be enough strong that we have made the thing stronger. And this was on the roof part. So the roof part that was designed is such that basically it should be also used as a force transfer mechanism, because the lateral part was flexible due to the hinging mechanism, so that we should having a very stiff mechanism at the top and bottom, and that we have given in the inclined seats that it will be not having any issue during the rain. So these are some of the glimpses that was done inside the laboratory, because that we cannot do it outside at that time due to this complete lockdown, that we have made everything in our heavy testing laboratory. This is a full scale, and it was done in the round the clock. So this is the height is 2.8 meter, this is 3 meter, and this is 6 meter. And as I was saying that this floor was very deep, and this was also the roof. Generally that we cannot be steep because that we can give some incline members, but because to make the structure stable under a very strong wind also, that was a requirement that we should give that, and also that should be having a proper force transfer mechanism. So that we are showing the bare picture so that it will be easier for you to understand that kernel. So what exactly that was there inside the structure. So then that we have started putting the cladding. And this is, if you see really, this is the folding mechanism. I was telling that this was having a very heavy duty hinges that were put, so that it will be having that complete force transfer that when it is coming as a vertical and this lateral. And then when it is coming as perpendicular loading that we have done by using the extra bolt that was given here, so that if these extra bolts are there, that will be created, that it will be resisting the structure to getting it folded, and it will be giving you the additional path for the post transfer. Okay. So I'm just repeating it again because of the hinge. There was a directional problem will be there. That one is the along the width and along the length. So along the length to have the things so that you have put the proper hinge with the heavy duty hinge. So along the longitudinal force, it can transfer well. When this having along the width, the lateral force is comes, then this hinge is trying to make it to be folding. That time that was really arresting mechanism was put, and this is the zoom view of that. And that was actually movable, so that at the time of the dismantling or having a folding, with the transport, that you can just unplug and you can put it, so that the hinging mechanism it will be getting activated. Now the industry, when we had actually interacted with some of the stakeholders like the hospital or the industry, they have raised a question that, see, there's having no time because the time is very short. If you tell us to make a foundation, I think that all of us know that foundation that which goes underneath the soil, it takes a lot of time, complexities, and a lot of money. So they said that we should have a very simple foundation system, but it should be robust and it should be made very quickly. So then that we have made with the innovative way of doing the fixing the entire structure with the clip things, and it was made in such a way that even for the lateral load, whatever is being imposed due to the wind load, it will be able to resist. So this requirement just to lay some lane concrete, and one thing is that you can fix. And after placing this foldable hospital, you can just make it plug it. So I think that will be made the thing support system. Now the next question or the next concern, basically not a question, it came from stakeholders that what is the durability and the water tightness of those structures, because it will be folding, so it will directly benefit from here. And if you use for patient something medical things and all, it will be absolutely necessary that it should be completely watertight. So that we have used some special sealant, silica-based thing that can be given in place of this folding region, and also the place that where that you have given the puff and this one, so that it will be absolutely waterproof. And to show that the structure is completely waterproof, even now we have kept the demonstration module outside, so that in the years, because that is now it is at the third year is over, so that we are inspecting and seeing that whether this mechanism what we had adopted, it is able to really cater the requirement for the water tightness so or not. And the answer is yes. So it is still that is working well. So these are the though very minute things, but when you make a product and which has to go to the market immediately, so it should be having the complete solution by considering all the requirements from the user side. Now for the cladding that we have used, that is the puck panels, and that the puck will be having the insulators and will be having a metallic sheet, and metallic sheet will be having a stiffness, so that it will be acting as a wall and it should be giving a thermal insulation also. And we have made the structure, as I was showing you earlier, as a skeleton, and it was designed in such a way that you can just plug and play this type of cladding that can be given, so with no time, right? And this is the thing on the roof. Roof was, I was telling that this was the requirement from the structural side to give a stiffness. And this was a cladding that was actually roofing was given with a 5-degree the inclination, because that was the suggestion received from the industry, that so that no issue of the water stagnation on the roof it can happen. So that double weight that we have given it. And the floor was also made meticulously so that it can meet the requirement of the medical standard. After doing everything, now comes about the question that lights, fan, and all the utility things also have to be given. Now, this has given us one more challenge, is that not only an optimized design, not only load, not only trace, not only the functionality. Here, that was told that all the electrical appliances, so that those items like the tube light, the switches, the line for the tube light, everything should be inside the structure. You cannot install at site. So the design and the orientation should, the member should be such that after folding of the whole thing, also the lights and the switch and all should be intact, and it should be able to function when it will be unfolded and getting it plugged. So that was a very interesting problem that we had got, but that we had also solved it in this way. So that we had made the members in such a way, and that we have put the tube lights and here this point, this plug points and all the things such a way that even if it is folding the fully thing, also the tube lights gets intact. So that was done, and also that we have tried, I think, few times that's happening correctly. So that will be having a plug. You go to the side, make it unfolded, put the plug on, and that's it. Then that can be made use of, except the medical requirement. So that has to be installed later based on the advice from the medical officers or something like that. So this is the final product. So after all things done, at ACRC, that we had proudly made these things, and we have declared that that the thing is that the product is ready, that the technology is ready. Now that we saw that, and that can be open to the people that who can be getting benefited from this one. So this is the total sequence. So that if you make it, so it is the folded shape. It was having the height is less than a feet, right? I think that it was just 0.3 meter was told, but it was a less than a feet. And this is so first step of the folding. I think in the next slide, I think that is having nicely. Yeah. So this is the initial position. After that, it is getting it unfolded, and this is the unfolding of both the sides, right? And then that we are putting the front and back sides of the things. And I should tell you one thing. So this member alone is not sufficient for having the loading that has to be taken care during the wind load or all this dead load. So after this door is getting locked here, so this member and this side member, they will be acting together. Okay, so that's why that was made a very optimized, slim and light sections were taken. So this is the next step, and this is the interior thing that I had already shown. So these are the steps of the 5 steps, how the sequence of the operation for the erection of the PoliTal-M it can be done. Okay, so in the gist, so this is the modular unit. Each of the unit, it can take 2 to 3 beds. Finally, that we have come into the conclusion that if you have to accommodate many medical equipments and all, that we can go for the 2 beds, and it can be erected by half an hour. I have told it at the later also to give you the glimpse. And if you have to, as we say, that if you're having a cluster, so that you're having isolation ward, then the medical staff, then the COVID positives and the toilets, all can be made by using the units, and it can be made aligned with this one. So that as a total system, it can work. Okay. So this is the thing. Now the salient features. So I have almost told, have described here everything, but I just want to put the things at the concise form so that we can take home that some salient points. So the modular unit is a single foldable unit. That is the one unit I'm talking about. It is around 1 ton. And if in case you see that some of the cases the wind load is not predominant, then we can make the sections for that particular site much lighter, so that this weight can go further lower. A fully foldable that can be taken and erected by a level ground. I think that was one of the major requirements, that they cannot afford to having a foundation requirement because of the time, cost, and also the feasibility at site to get all those things. The wall panel consists of 4 panels with the cladding, and are provided with the heavy duty hinges. I told that it can be used as a structural system which will be giving you a path. And the modular system, I showed that this is the size in the unfolded stage. And the whole process, this is a very important thing, the whole process of the unfolding or the folding the whole thing, it will take almost like just like 1 hour time. and it can be made ready for use, and with only 2 to 3 labors it will be required to just to install the module, because at site that will be very much important to have very less labor intensive thing, and multiple units it can be stacked together, that is the opening of the communicating for the one unit another. Okay. And so some of the units, so I have shown you earlier, some of the unit can be used as a toilet also, because nowadays in many cases the stakeholders are coming to us to see that whether it can be used for that makeshift type of structure where you can use for the toilet for some of the gatherings in the urban area. So the key benefits as technology. So that will be requiring a 2 to 300 unskilled manpower, and you can go around the 100 grades of the whole system, including the electricity and the water supply. So all piping it can be accommodated in the panel, including the switchboards and pipe connected, because that was a very challenging thing actually for us. We are the structural engineers think about structures, but when it comes about the other requirement, and on the top of it, the requirements have to be built in the system before we fold in. So that was very interesting, and it has been adopted a simple erection methodology just for unfolding and things. And because of a very small size during the unfolding, that you can take 5 to 6 that units at a time that to the site. I think that caters a lot of requirements of the things. Okay, so though it was developed at that time in 2020, I think in the month of April, May, June time. So that's why then the title was given as a hospital and the other needs. Then that you have seen that it can be used as the temporary housing or the shelters for the unemployed events, and that obviously it can be used for the temporary medical hospitals. And that nowadays that we are getting some requirements from different construction industries is that for their laborers at site, they need some site accommodation. And after that site is over, they can simply pack and go to the next site. That requirement has also come up, and this technology would be very good for that. And portable toilet unit, as I told, that from the urban gatherings or some sort of occasions that can be used. And in strategic sector, that we are in the top with some of the defense organization that in their inaccessible areas, so they wanted to set up some of the houses for some requirement. So there also to transport those things and to erect and to dismantle and come back. That was told that it will be an ideal solution for them. Even that we are also in the talk with the NDRF and all that, whether it can be used during the disaster, natural disasters. After that was done, and that we had made the things open to the people and the stakeholders and all to see and to get into the things. So then that has actually caught the attention very fast. So it is the news in the Hindu has told that now a foldable portable shelter. So that has come. And in the business line also has covered this story of the foldable hospitals. And also in our India Science, Technology and Innovations, that the Government of India side, if anybody is interested in that audience, they can go into this and they can see all the details are available. And also that you can always approach to us. So anytime that we'll be happy to give you or to share you all the information. And basically then L&T came to us and they wanted to see the things, fully that how it is working and what are the things. So this is a glimpse of the discussion. I think it is in the month of October, something like that. I think in 2020 that we are in the discussion with the L&T officials inside the portable hospital. So that was being demonstrated at SERC. So even now that is there. And this is the glimpse of after the successful one that we have made them to understand that how it can work. So then that we are having the technology transfer meeting. It is our Dr. Mandit, the former DG, and so he is the VP from the L&T, and that we are having that technology transfer. And before I end, I just want to give you I'll just give you a brief video so that it will be.
PoliTal-M, an innovative, lightweight and foldable structure developed at CSIR SCRC. PoliTal-M consists of a steel frame structure made using standard steel sections available in the market. The structure is of collapsible modular type that can be fabricated in a factory, and the complete structure in folded condition can be transported to the site for quick installation, such as setting up of temporary hospital or housing facility during pandemic or natural calamities. Each of the module is of 6 meters length, 3 meters width and 2.8 meters height, and completely folded stage is of 6 meters length, 3 meters width and 0.3 meters height. Each module is made up of separate frames joined together using heavy-duty structural hinges. The integrity and stability are ensured by using pin and bolt arrangements. The completely folded structure has a total weight of approximately 1300 kgs. The module can be fabricated in the factory, welding standard steel sections, and can be transported to site and placed using a crane on a leveled concreted surface. It can be easily anchored to the ground using a detachable.
Okay. So this is the thing. And if anybody is interested in the ACRC website, also the technology brochure is there, because many of the industries are getting this information from that brochure. So this is the thing is there. So that I have given that also that link here. These are having a salient points and how it works. And this was developed by Dr. B. Srivasan, that is there with me. So, and it was transferred to L&T Construction immediately, actually, after it is done. Even the Prismac infrastructure actually pioneer on developing such type of the makeshift structures. So they have also taken that technology. And the interest has been shown by many organizations, including the recently happened to having a BSF and the NDRF. And we are also in the talk with L&T. They have got a revised requirement with the improvised version they want for much more the things. So that discussion is also happening, but that is not for the hospital. That is for the L&T particular thing. So they wanted to take the technology forward. So they want us to work on that so that it will be helping not only them, any construction industry will get benefited. So it was substituted from something, and it has given a very good technology, and it can be used for the many ways and many forms. And so many industries and the organizations are actually expressing their interest to have it there. So with that, I want to thank, but before I thank, I want to really profoundly thank our director for giving us, myself and Dr. Srinivas, to give the opportunity to make the things and given the trust to us, this can be delivered in time. And also that we want to thank the DGCSIR, to Viva ma'am, and also that ma'am for this opportunity to share with you all as the CSIR family that what we have done here. And we are not only happy to talk on what we did, also we'll be happy to get some comments, some suggestions, some views. Also, if somebody is also interested to go further to help us to get the value addition to this also, that will always come. So with this, I'm just ending this presentation. And if anybody has any queries, questions or comments or suggestions, please let me know.
Thank you, Dr. Saswal, for your illustrious presentation on portable, lightweight, foldable module for makeshift hospitals and other needs. We will be having a question answer session. Before that, I, Dr. Bhanu Verma, would like to have some questions. Of course, there are 4 or 5 questions that come to mind immediately. But the most important question from IP perspective, I would like to ask that you have designed this portable, lightweight, foldable module, which can be applied not only for hospital purpose, but also for housing purpose, for disaster mitigation, or other utilizations like you said, for toilet installations and for housing installations or similar use. It can be, I understand it can be used for even other industrial. Can you all be a little, yeah, I would like you to please put off your mics and please raise hands for questions if you have any. So I would like to ask you, have you got this a module, this your portable lightweight foldable module? Have you got it registered as patent or design, industrial design or design, something like that? Have you got an IPR on that?
Yeah, actually, madam, the answer is no, because that we have not taken any IPR on that, because that time, there is the major requirement was that we have to bring a solution which has to be transferred, so that we did the technology transfer. That was the IPR that was not taken.
We understand that. We understand that, but we will like to take this opportunity that this is a very wonderful system that you have developed, and we will like to take this opportunity to get across to all our audiences who have joined, all the scientists and across CSIR laboratories who have joined, that though it was an immediate requirement and need, even during COVID era, IPU was not sitting idle, and we were doing filing of patents and any other form of IPR, and we would have very much appreciated if these kind of technologies are registered, if not for IP, if not for patent, if it's not patentable, at least for design, because I understand, because it would be a novel design, if at all it is a novel design, first of all. So this is an important step for any technologies that are developed in CSIR. We would like to encourage each and every scientist and technical officer or anybody who is working in CSIR system in a scientific domain and developing new technologies, that they come forward and register their technologies in any format of IP that they are bracketed into. Second questions that I would like to answer is, yeah, please.
Actually, what you said, madam, that is it's very actually that we are happy to note that. And actually, what we are doing, that was the requirement at that time, with the pressing with time, and it has to be delivered, that we had given. What we are now doing, Dr. Srinivas and myself are actually improvising the entire thing, and we are doing something novel. And I think now that we are having an ample chance that we will make the whole thing. And as you, madam, told that we will go for the IPR first, and that we will be registering the whole thing, then that will go for that step of the industry things and all later. So that, madam, that we are making it.
Yeah, keeping in mind that it is having inventive step and inventive step above and all, which the technology has already been transferred or developed and transferred, because it is now in public domain. So keeping in view that there is some novelty and inventive step in the technology that you are further improving and developing for this technology. I understand that this technology is a specific size module, and it can be used in various purposes, but is this technology that you have said, that limited size module 6 into 3 into 2.5, which is a unfolded model, can it be scaled up? Because this is a limited structure. You have made a box which can be folded and unfolded, and it can be used for certain purposes, which can be used or utilized in either in mostly in disaster management, even if it is for hospital or for residential or for any other purposes. But can it be scaled up to a bigger size for different purposes? So, for example, if you are having any exhibitions, if you want to have a unit for that, if you are having some other off-site office module where you want to, for example, you are in civil zone, and if you are having a site development for bridges or something like SARC works in a structural wherein you are having off-site a big site where you have construction going on, and if you want to have a hospital module or office module, so can it be scaled up and can it be used for any different purposes than the size which is specified here, which is kind of a room size, which I understand, if I understand correctly. Can it be scaled up to a bigger size, and would it be stable, and would it be a little more sufficient to meet the needs of that kind of structure?
Yes, madam. The answer is yes, a very big yes. because here the 6 meter, the number 6 meter came because it was the discussion came that when you transport from one place to another place because of the heavy duty trucks, they say that if it is a more than 6 meter, there is having a logistic problem. But if that is the case, but as a structural engineer, and if be particular the technology is concerned, it can be made of so the sizes as it is required. So that can be made as it is required, madam. And as you told that if you have to make the exhibition hall, so it will be much bigger. If you have to make some requirement that is not like a small box of a 6 meter, it is absolutely yes, it can be done. That it can be done, and it can be also proven that it is a resilient, it is a disaster free, it is a durable, everything. So only the thing is that it was made such that to transport, as some of the stakeholders told that they need this height only for that.
This is just a kind of a question along with a suggestion inbuilt in that question. So while you are improvising the technology, I hope the thing that comes to my mind as a novice in your field, I would go to the field of implementation where it can be installed. And the development part is not my field. So that is why I come with this question, and I come with the suggestion also. We have our, before I give the forum to Dr. Deepika, who is along with me, and she's going to take question answers with all that. My head is online, and she would also like to ask some question. I think she's raised her hand. So, ma'am.
Yeah, Dr. Sasamal, congratulations once again.
Thank you.
I'm familiar with the work that you've done, but what I wanted to know was what next? This technology is transferred, but what is your take on popularizing this, promoting this, and also going forward? As I know, I think this technology is transferred on non-exclusive basis, right?
Yes.
Yeah.
Yes.
So are you looking for more partners? And
yes, madam.
for
Actually,
this,
Actually, madam, that we are, because that's why the purpose was that we wanted to having a non-exclusive basis. Yeah. And we are talking to some more the industries. And also, as we had mentioned, Dr. Srinivas is also talking to the BSF. They are telling that is their very much requirement to have it. Even the NDRF also came that they wanted to see the thing, how it can be, because they feel that in some disaster structures that time that they need to give some houses for those people. So having said that, that is the thing on what the technology is available. Also, as I was mentioning that for the improvisation, so that we are getting many more requests now because that has now come. They are thinking that it is a realistic solution. Now they want more and more. So they want to not having a vertical folding. So whether it can be done as horizontal folding, it can be having a double story. So whether it can have, I think there are many things it can be done. So we are not taking that everything at a time. So that we are systematically unfolding it. But I think that I think very soon that will be coming into the point that so this also it can come, the new one.
So in fact, even very well, CBRI also has a similar technology available. You know what the structural difference, if any, between the two. Secondly, AMPRI, labs like AMPRI and all, they are working on alternate materials as well, other than wood. So they've come up with those parali boards, and also they're coming up with other boards, even bamboo for that matter. So it'll be a good idea to, get into discussion with AMPRI also, as also other labs, and then try to make this kind of a complete technology, which is not only scalable, but, where you are able to use any kind of material. So that's a suggestion. Maybe you could think of it, and we can discuss this further offline.
Yeah. Actually, madam,
thank you and all the best.
Thank you so much, madam. And actually, that we know some of the works by that AMPRI, Dr. Asakan Papu is doing it. That we are very closely also to have discussions, so that we will be discussing with him again, so that we can make use of those things also, so that it will be much more as a CSIR things.
Yeah, so that's what.
Yeah. Yes, madam. Yes. Okay.
Thank you.
Yeah, so
And,
I would
and
like
please find as many IPs as possible around this technology, right?
Okay, madam.
Certain
Surely,
things
madam.
were missed during COVID, but then we should not let go of this.
Yes, madam.
Right. Thank
Sure.
you. Thank you so much.
Thank
Over to you, Bhanu and Lipika.
yeah. So I will give to the mic to Dr. Lipika, who will be taking further question answers.
Thank you very much, Dr. Sasman, for this very enlightening talk on portable, lightweight, foldable modules for hospitals and other needs. Sir, you have shared your journey. You have provided insight on and where and how the requirement needed, and how you have faced the further requirements and challenges, and how you have raised the TRL level and the technologies transfer. A very truly remarkable insight into this, and you have provided us an understanding of this particular field and the innovative opportunity in this particular field. So now this floor is open for question answers. I request the participants to raise your hands when and once called upon. Please introduce yourself and followed by your questions. You can also put your questions in the chat box, which I'll be taking up forward the speaker. Thank you.
So there's Dr. Chandrasekhar.
Yeah, sorry, I'm Vishnupriya from CCMB Hyderabad.
Vishnupriya, you can't do that. Okay, go ahead, please.
At the outset, I would like to congratulate the inventors for this wonderful work from CSR, and it sounded very, very, situation demand, and it was met, and we all feel very proud to be under this system. So I could not figure out, I mean, if you could draw the financials between really the concrete building and this erectable, portable makeshift hospitals, I think then the impact would have been, will be much more. I'm sure people in the field may be understanding, but some of us who are out of the field may not be able to estimate that. And as Vibha pointed out, and the IPU team, more of IPs. And off late, so moving to the next, then we could see all these recent calamities which we are facing through floods and all. So probably, where very big shelter places can be made in certain areas where we are facing calamities. So that would be another very good, output of this foldable makeshift units. Thank you.
So may I to give a short answer? Yeah. So actually that we have done the costing also. And in the one of the slides, actually it is there, but I was not emphasizing that because this forum is not for that. So it was coming around 1100 to 1300 per square feet. I think that was much lower than whatever is the required. Second thing is that a concrete or a steel building, the purpose is different. It will be so heavy, it will be so robust, you cannot transport or you cannot make it within a day. So some of the clients, they need it with it, so that we had to first cater the need of the functionality, and also the cost matters. So and also that made it very optimized that the material cost, the transport cost, the erection cost, it can be minimal. So that we said only 2 people that you can make it erected. And the cost was made that all loads have been taken into the consideration of design with an optimized section.
Yeah, thank you so much. Thank you.
It's it. Thank you.
Any further questions?
Will like to put your hand down, Dr. Vishnupriya? Yeah.
And before I forget or before this ends, I should tell that Dr. Srinivas was the pivotal of these, and he was the energy engine for the entire work, so that both of us are here. If anybody has got any questions or queries, you can raise here, or that we are the CSIR one family, that you can drop a mail to us, that we'll be happy to answer. And that we may require Bhanu ma'am and Viva ma'am's support later, that whatever that we are developing, I think first that will go for the IPR related thing. Also some of the guides, something guidance that how we should proceed, and then that we can go.
We will always be there to support whenever we have any IP regarding issues which are sent to us. If there are no further questions, I would like to invite my colleague, Dr. Ms. Ajeta Agarwal, to present a vote of thanks. Ajeta, are you there?
Yes, ma'am, I'm there.
Please do. Please.
Good morning, everyone. Good morning, everyone. At the end of this program, on behalf of IPU, I would like to extend my sincere thanks to our DT ma'am, Dr. N. Kalaiselvi, for inspiring us to hold this webinar series. Thank you so much, ma'am. A big thanks to our director at ERC, Dr. N. Anandavalli ma'am, for nominating Dr. Saptarishi Sasman for this program. A heartfelt thank to our head IPU for constantly supporting us, encouraging us to hold this program. Thank you, ma'am. On behalf of CSI family, our sincere thanks to our family member and guest of the day, Dr. Saptarishi Sasman, for sharing his experience and providing immediate solution in this pandemic situation. Thank you so much, sir, for such a wonderful session. I'm sure your research and journey will inspire all the participants who are available today. A big thank to all the participants for making this IP campaign, this series, and this Rashtriya Bauddhik Sampada Mahotsav a successful and a memorable one. Last but not the least, thank you to the team SCGD, team IT, and all CSI members for helping us in hosting this webinar series. Thank you to all of you. Thank you, Dr. Bhanu.
Yeah. So other than the thanks to the team which has been involved in monthly lecture series, I would also like to present my vote of thanks to Dr. Vishwajanani Satyagiri to include this program into Azadi Ka Amrit Mahotsav and to include the monthly lecture series of Dr. Saptarishi Sasmal in this series. And that is how we are conducting this lecture today, this time. Congratulations once again to Dr. Sasmal for giving a very wonderful and illustrious lecture on this. Thank you.
Thank you so much. Thank you all. Thank you. Namaskar.
Yeah. Namaskar.
Thank you.
Hello, ma'am, I have one suggestion. Hello.
Go on, Dr. Negi?
Yes, ma'am.
Dr. Negi from SIMA? Yeah,
yes, ma'am. Yes, ma'am. Ma'am, at last you should know. You should tell the name of the next speaker. It will be better.
Dr. Negi, this is not possible right now because we take a little time to confirm the next speaker. So today, this time, we will not be able to tell. But if you are ready to give next lecture, then I will specifically be happy to announce this. Because we have a next, and Director Simap has already nominated your name, I think. So if you are ready on this forum, I can on this forum, I can announce that the August lecture would be by Dr.